Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about storage parameters and a couple of terminologies. The first terminologies that we are going to discuss is called high water mark, or in short we call it HWM. So for this, for to understand this, what is HWM and then what is its significance. So let's try to see, envision, like whenever you are creating it, whenever you are having a table and you are trying to insert, all the blocks is going to be stacked from left to right. All right, so that means whenever I'm going to create a table T, right, so I have just a stack of block. So this is basically I'm going to start from here, right? There's a pointer is here. Then let's say what I'm going to do, I'm going to insert a couple of rows. So when I'm going to insert couple of rows to this table T, then I'm going to have a data block covered. Again I'm going to insert some more, so some more data blocks covered, more. And let's say right now my pointer, like this pointer which started at this point, has moved to this point. All right, so let's say we keep inserting, and let's say we inserted 50,000 rows. So if we insert 50,000 rows, maybe like what we're going to have, we are going to have multiple number of blocks filled like this, like this. Let's say at this is the point when we have 50,000 rows insert. And after that, what I'm going to do, let's say I'm going to delete 25,000 rows. So if I delete 25,000 rows, so then so basically this is our scenario where this is the pointer. So we have filled up to this point. Okay, so we have filled data up to this point, and whenever we are going to remove, we are going to delete 25,000 rows, then like this is, and all these blocks are filled and these are empty. But the high water mark is still at this point where it is up to the last possible insert. Okay, so this is the SWM, and after 25,000 rows deletion, the high water marks remains the same. Okay, and then we have, these are the empty spaces. Let's say we are going to add, after this scenario, this is the case, this is a step 1, so this is a step 2. Let's say after this time we are going to add 50,000 more rows. So in that case I'm going to have, so I'm going to have after this, so the total number of rows now is 75,000, so maybe something like this. So this is up to here is 50k, so we have add another 25k, right? So this all things are filled now, and then the high water mark is shifted to this point. So high water mark is up to the last possible insert. And let's say again in step 4, so this is how the high water mark is going to be up whenever we have 75k rows. And let's say after step number 3, we are going to delete the table. So if you delete the table, then this is what is going to happen. The high water mark remains same wherever it was at the step number 3, and then there is no row, it's completely empty. So I hope with this diagram you are able to understand what is high water mark. Then we need to understand what is the significance of high water mark. Say for example, we will add new blocks above the high water mark provided all the blocks below it are filled. Okay, so here is a lot of time people will ask you a question, what is the difference between delete and truncate? So to understand this, in case of delete, we are going to delete, say for example in step number 3, whenever we give a delete from T, then the high water marks remains here. Instead of delete, had I given truncate, then the situation is going to look like this. It's empty, but the high water mark should have shifted to this point. Okay, so truncate basically brings the high water mark reset to the original position at the step 1 whenever we started. Then what is the benefit of that? So here is a benefit. So let's say, so this is step number 5. In step number 5, basically what I did delete from T. In step number 5, I did truncate from T. So let's say at step number 4, after I delete, I'm going to give something called select count star from T. So notice that we don't have any rows, right? So therefore the value will be 0. But if you make the SQL trace on, so that you can see that this will take some time, because it is going to start scanning, the table is going to start scanned from the high water mark. However, if you have, instead of delete, if you have done truncate, then it will be faster. The select count star from T also will going to give you a value of 0, but in that case it will be faster because it will not be scanned at all. Because the rule is that whenever you are doing something, select count star, something like this, it is going to scan the table. Scan the table. It's called full table scan. All right. So we're going to do a full table scan. We're going to scan from where? From where we have the HWM set. In this case, if you have a delete, the HWM set at the very end. Therefore, scanning the whole table will take some time, and then we are going to get we're going to get 0, but it's going to take some time compared to truncate. So therefore, if you are planning to really delete the complete table, don't give delete from T, just instead give truncate from T. In that case, it is going to reset the high water mark. Okay, the next concept I am going to discuss in this thing is called free list. So every table or every object will have a free list. Free list essentially contains which are the block that are free. So for example, in this case, like so let's say now number the block. Say 1, 2, 3, 4, 5, 6. Okay, so essentially free list will contain the blocks which are under the high water mark and they are free for further insert. In this case, after I delete 25,000 rows in step 3, my free list will contain block number 5, block number 6, because block number 5 and block number 6 are the blocks that is under the high water mark, right? It is below the high water mark, and those things are empty, or those things can be, we can insert data, or you can insert the row. Whenever you're going to do the next insert, we are going to insert into either block number 5 or block number 6. In step number 4, let's say we are going to do a delete. In that case, our free list will contain 1, 2, 3, 4 up to 6. Whatever the number of blocks that we had is going to contain those things. Okay, so actually whatever number of blocks we have, because we have more number of blocks added because we added another 25k here, right? So therefore free list will contain those things. And then what is the free list will be if you're doing a truncate? Nothing, because there is no block below the HWM. Okay, so think about that. Free list basically will have a list of the block that is going to be where we have some empty space which is eligible for a further insert. Then the question is why you are maintaining the free list. Okay, the reason behind maintaining a free list is that next time we are doing an insert, okay, the first thing is going to Oracle is going to do it is going to look at the free list of that object. In this table T, assuming that we have only one free list, name it free list 1. First thing is going to be seen. Before I'm going to insert anything, I just want to see if there is a available block on the free list. In this case, say let's say after number 2. Okay, so after step number 2, there are two blocks, number 5 and number 6, where I can insert. Therefore I'm going to take a block, say number 5. In number 5 I'm going to try to start inserting. Okay, then let's say eventually if I do insert more, I keep inserting, then eventually I'm going to fill block number 5, then I'm going to fill block number, let's say 6, and after I fill block number 6, there will be the free list will be nothing, the free list is empty right now. Then what I'm going to do, if still I'm going to do insert, Oracle will allow another block here, and then it will relocate the SWM to the next one. So this is the SWM, and then I have the block number 7 is allocated right now. Then I'm going to keep inserting, and then once I keep, if I keep if the insertion is again completely, like now if I still keep inserting, and I'm going to like basically use all the space here in this block, then again SWM is going to shift, and then I'm going to allocate another one. The rule is, first thing that I'm going to check before I insert, I'm going to check a free list, and then after that I'm going to insert. Then another thing is that if I'm going to still delete, eventually, like if I'm going to delete this block, the rows, so that I'm going to remove this, I'm going to delete this this block, and at some time what I'm going to do, I'm going to take this one to the free list, because this is again available for further insert. So here is a deal that I told you right now. For every table will have one free list. By default you will have one free list. But let's say in your in a database we are doing a lot of insert, like a lot of users are trying to insert to table T. If in that case everybody is going to come and take a look, like before an insert happen, it will check the free list if there is a block available for insert or not. That means if we have concurrent, multiple concurrent inserts is going to happen from different users, then all of them is going to come and take a is a wait for this free list, because this free list will be accessible one at a time. All right, so that means we might introduce a contention. Okay, so we might introduce a contention, and then your performance may suffer because a lot of other users are going to wait on this free list. To solve that one, we can increase the number of free list for this object. Let's say for example, if whenever you are going to create the table, you give a command like create table X and say a number, and then if you just give like this, it will create one free list. If you want to multiple free list, then you give storage free list is 2. So in that case, what's going to happen, for this object X we are going to have two free list 1, and then another is free list 2, and then so some empty blocks will be stored here, and some empty blocks will be stored here, and therefore whenever this insert 1 is happening, it might see the free list. If at the same time insert number 2 comes, then it's going to look at the second free list. So that way I can take away the contention on the free list, but I may have added some extra space because there's two lists right now. Okay, and then also I need to manage it in a coordinated way. The Oracle need to manage it in a coordinated way to make it work. But it's worth to take a look at the to tune this parameter if you are doing a lot of insert to this table X. In the next slide we are going to discuss about two other parameters, and those parameters are going to determine, let's say for example this block I'm keep deleting, right? I'm keep deleting data from this block. I need to know at what point this block is eligible for an insert. Okay, that means at what point I'm going to put this block, I'm keep deleting, I'm going to delete completely that block, or I'm delete to certain percentage. At what case, at what circumstances that block is going to be a part of the free list, or that that block is going to be registered on the free list as an empty block. Is it completely deleted or just a certain percentage deleted? And we are going to discuss in the next video about two other parameters which will tell us more detail about those things.